Hello and welcome to this math class. We have this question here. The question says bracket m plus 7 close bracket all to the power of 7 equal to m to the power of 7 plus 7 to the power of 7. So what is the value of m here? So let's see how we solve for this. All right, so we take our solution. All right. Okay, so the first one here we have m plus about 7 all raised to the power of 7 equals to m to the power of 7 plus about 7 to the power of 7. Now this is a heavy exponent. So how do we solve for this? We're going to think of some algebraic identity that will enable us to solve for this. Okay, so I have to make research to getting expression of this kind in our algebraic identity that will enable us to solve this. And I came up with this. We have this that if we have our bracket, let's take our x right here, x plus our y all raised to the power of 7. This is equal to, we have our x raised to the power of 7, then plus 7xy, the bracket, our x plus y close bracket, then bracket our x to the power of 2, then plus our xy plus our y to the power of 2, then close bracket all raised to the power of 2, okay, then plus our y raised to the power of 7. Okay, so I was able to come up with this algebraic identity. So with this algebraic identity, then we can solve what we have in here. Okay, so let's rule this of this what we're going to use. In solving this expression. So this side of our equation is of this form. So we have to rewrite this expression in this format, keeping this side of this. So this now implies, so with here, we have our x to be m and our y to be 7. So this can be written, again, we want to express this side in this form. So this is going to give us our m to the power of 7, then plus our 7 times our m times our 7, okay, because our y is 7, then bracket our m plus our 7 close bracket, then bracket our m to the power of 2 plus our m times 7, then plus our 7 to the power of 2, always to the power of 2, then plus our y is 7, right? So we have 7 to the power of 7. Mind you, everything here is equal to this. So this is equal to our m to the power of 7, then plus our 7 to the power of 7. Okay, so from here, you discover that we're having m to the power of 7 on this side, positive, and we're having m to the power of 7 on this side, positive also. And so this, we go with this. So if this cancels this, then we check out again. We are having plus 7 to the power of 7 here, and we are having plus 7 to the power of 7. So this and this will leave. So on the right-hand side of the equation, we are left with just 0. So we now have this to be our 7 times 7. This will give us 49 m, then bracket our m plus 7 close bracket, bracket our m to the power of 2, then plus, here we have 7m plus 7 to the power of 2 will give us 49, then close bracket, all raised to the power of 2, then here we have nothing, so this equal to 0. Okay, so with what we have in here now, here we want to apply what we call the zero property, whereby we can equate this, we can put this in bracket, we can equate this to 0, we equate this to 0, and we equate this to 0. So we have 3 cases here. So let's take the first one. So we have case 1. So our case 1, we have 49 m to the power, equal to 0. So if we divide by 49, automatically we're going to have m is equals to our 0. So this is our m1. So m1 equal to 0. Does it satisfy the original equation? Let's check it out if it will actually satisfy the original equation. So from here, we have 0 plus 7, that will give us the raised to the power of 7, that will give us 7 to the power of 7, right? Then if we come to this other side, we have 0 to the power of 7, that will give us 0. Because 0 to the power of any number, or 0 raised to any number is 0, except our 0 and iota. Then we have here 7 to the power of 7. So we're going to end up having 7 to the power of 7 equal to 7 to the power of 7. So now let's take our second case scenario, which is this. We'll have here case 2. So our case 2, we're going to take here, which is our m plus 7. M plus 7, this is 7, please, equal to 0. Okay, so let's continue here and see what this gives us. All right, now from here we have m. Let me rewrite this. This is equals to 7. So move this to this other side. So we're going to have 7 is equals to minus 7. So this is our m2. So this is m2. All right. So if we also check if this will satisfy this equation, you'll discover that it will satisfy the original equation, because if we put in minus 7 here, so minus 7 plus 7 will give us 0. The 0 to the power of 7 will give us 0. Then we have here minus 7 to the power of 7, then plus 7 to the power of 7, that will give us 0. Okay, so it shows that this also satisfies the original equation. So we take the third case scenario here, which is our, let's take it here, our case 3. Our case 3, we have our expression, which is m to the power of 2, then plus our 7m, then plus our 49. This is equal to all raised to the power of 2, okay? But let's keep that. So if we are to raise this to the power of 2 and we send it to 0, then we take the square root of both sides, we are going to end up having just 2 solutions from here. But let's keep this aside, okay? Because at the end, we're going to have 4 roots from here, plus the other ones we'll solve for. That should give us our 6 roots. And why are we having 6 against the 7 we are supposed to have here? Because if we use this to open this, we're going to have m to the power of 7 from here, and we also have m to the power of 7 from here. So one of them, we cancel the other one. There we are now left with just 6 roots to this challenge. Okay, so if we have to solve this, we are going to use the formula method. Using the formula method, we're going to have our m is equals to minus our b plus minus the square root of our b squared minus 4ac, right, all over our 2. So because of space, let's come back to this place here. So if we substitute, we're going to have our m will now be equal to, what is our b? Our b is 7. So we're going to have minus 7 plus minus the square root of our 7 to the power of 2 minus 4 times our 1 times 49. Okay? Everything all over 2 times 1. So if we simplify this here, we can express 49 as 7 to the power of 2. And so this is going to give us minus 7 plus minus the square root of, here we have 7 to the power of 2. And because we can express this as 7 to the power of 2, so we're going to bring 7 out. And if we factor out, we're going to have here 1 minus our 4, those brackets, all over our 2. So because this is square root, the square root, and here we have square here, so that can come out. So if that comes out, then we're going to have here our minus 7 plus minus our 7. Then we are now left with 1 minus 4. which will give us minus 3. And minus 3 can be written as minus 1 times 3. And if we bring in our iota, we say that if we have your square root of minus 1, this is equals to our iota. And so this expression can be written as our iota root 3 all over our 2. So we have two roots from here. We have our m3 and m4. But remember, this is raised to power 2. Now look at it here. This is raised to power 2, right? So we are going to have this expression into two places. In other words, we're going to have 4 roots from here, plus the existing 2 we have here. That will give us 6 roots for this a polynomial equation. Okay, so this brings us to the end of this math class. So we have 4 roots as a reminder from here. Then we have this and this. And these are the 6 roots that satisfy the original polynomial equation. Learn something from this video, drop it in the comment section. See you in our next class. Bye.